Welcome to another tutorial on binary numbers. In this tutorial video I'm going to be going through how to convert a decimal number to a floating point binary number. I've got this example question here. I've got to convert the number 23.25 to floating point using 10 bits for the Mantissa and 6 bits for the exponent. I've got the steps of how to do this process over here. And our first step is to convert the number to binary. And the way we do this is using the method I outlined in my fixed point binary video. So I'm going to write out my decimal numbers. And being careful to include the fractions here. So I'm going to now use my method for converting a binary. I'm going to use my method for converting a decimal number with a fractional part to a binary number with a fractional part. And I've got to be careful here because I've got a fractional part, so I'm going to, and that's 0.25, so I'm going to say no halves, 1/4, and no eighths, like that. And that's my number in fixed point binary. The second part of this process is to find the number of spaces the binary point must move for the number to be normalized, and that's the exponent. So this is how we find out exponent. And if our binary number is normalized, we've got a positive value here. So for our binary number to be normalized, our our binary point is going to have to be between the most significant one and the next zero. So in this case, if I write out my original bit pattern again, I'm going to count how many spaces I move the binary point along until I get it to here. And that's 5 spaces. So our exponent is therefore 5, and in binary that is a 4 and a 1, so we'll write it out here. My exponent is going to be 5, so I need 1s there and there. That's our exponent. But notice it's got to be 6 bits. We've got to use 6 bits for our exponent, and we'll come to that in part 3. So moving on to part 3 of the question then, I'm going to write out my bit pattern normalized as I did in this step. So it's going to be a 0.10110, and my exponent here. I've got to ensure that the Mantissa and the exponent are the correct number of bits. And in the start of my question, I've got to use 10 bits for the Mantissa and 6 bits for the exponent. And I can see here I've only used 4 bits for the exponent, so I'm going to add some bits to the end here. I've got a pad with bits here to make it the right number of bits. And this won't change the number, it will just make the bit pattern the correct number of bits. And I'm also going to check my Mantissa. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. So I'm going to pad with zeros on the end here. So I've got 10 bits there. Okay, and that is my Mantissa. and my exponent. And in a few moments, the second part of this tutorial video will come up, and I'll be doing this but with a negative decimal value.